Video will cover section 4.2, trigonometric functions and the unit circle. So the definition for trigonometry is, for the word trigonometry, it means the measurement of triangles. And so the unit circle, just like the name tells us, is a circle with a radius equal to 1. And of course you know that already. So the equation of a circle, just so you remember, it is x squared plus y squared equals to 1. This will be a circle with a center at the origin, just like this one here. And then the radius is equal to 1. So this is equal to 1, and so is this right here. Okay, now in the unit circle, the radian measure of the central angle, and remember, a central angle is an angle that its vertex is at the origin of the circle, or the center of the circle, like that one here. So that's a central angle. So in the unit circle, the radian measure of the central angle is equal to the length of the intercepted arc. Okay, so let me explain to you what that means with the graphs. So from last section, we looked at this formula. Do you guys remember what the S is for? The arc length. And then R is the radius. And then, of course, the theta is just the angle. Now, for this section, we're going to be using lowercase t for the angle. I don't know why. That's just how the book made it. So based on that statement that we just copied, if we try to substitute this radius in the angle measurement, the radius, we're talking about the unit circle, so the radius is 1, so instead of r, we put a 1. And then for the angle, we're just going to change the variable. So instead of theta, we're going to call it t. And what is 1 times t? T. So what this tells me is that the arc length is equal to the same measurement of the central angle. This only occurs whenever the radius is equal to 1 in the unit circle. And so from there, we're going to get a lot of trigonometric, we're going to get the trigonometric ratios based on that. Now, just so you know, who has taken geometry before? Raise your hand. Okay, who is currently taking geometry? Okay, so have you guys covered triangles? You're around that, right?
Yeah.
Right, okay. So there are two words, similar triangles and congruent triangles, right? So congruent, they're exactly the same. And then similar, who remembers what that means? Similar triangles have the same, well, okay, yeah, sure. We'll take that. What else?
Same angle.
Same angles. And what about their sides? They're not the same. They are what? Say that?
Corresponding.
The corresponding sides are what?
Proportional.
Proportional. Yes, yes. So if we take the ratios of corresponding sides, they're going to be proportional, right? Very good. So right here, if I just draw a line, I will have this tiny triangle, right? And so if I draw another circle around it, and then I'm going to try to, I'm going to extend here the radius, and then I'm going to draw the same triangle. Okay. So what can you guys tell me about the triangle in black and the triangle in red? Their sides are proportional, so they are similar triangles. So let's draw one more circle. And so if I extend the radius, it's not 1 anymore, but however, my so now the green triangle, the red triangle, and the black triangle, they are all similar, right? So then what's going to happen with the ratios? They're going to be congruent or proportional, I should say. So because of that, we can use the unit circle and then translate it into a circle of any dimension, of any radius. Okay, so now the 6 trigonometric functions are called sine, cosine, tangent, cosecant, secant, and cotangent. You will not refer to them as SineCosine, okay? That is just the acronym to remember them, right? But what it means is that you have the opposite side divided by the hypotenuse. That is the sine. We'll go back to that. Before that, the abbreviation for sine is SIN, cosine COS, tangent TAN. So you will not say sin of 30 or sin of pi. You're going to say the whole word, okay? I can't stand when people do that. So it's not sin, cos, and tan. It's sine, cosine, and tangent. For cosecant, the abbreviation is, CSC. For secant is SEC. And for cotangent, it is COT. And so we're going to learn a lot of things that they have, a lot of relationships. And I can tell you right now that here, those two are like cousins. And they're actually, we have a word for it. They are reciprocals. And cosine is the reciprocal of secant, same thing. Then we have tangent is the reciprocal of cotangent. Okay, so let's go back to this thing, and I know that in other classes you use this SineCosine thing as a acronym or mnemonic, just for you to remember what goes where. So for cosine, we have the adjacent divided by the hypotenuse. And then for tangent, we're going to have opposite side divided by the adjacent side. All right, that's what it means. So if we go back to the unit circle, and you know that this is equal to 1, and let's say that I just draw a triangle here. What will this side be equal to? If this is a unit circle, the red side should be equal to what? To 1, because it's a unit circle, it's the radius. Okay, so when we talk about the hypotenuse for triangles in the unit circle, the hypotenuse is just going to happen to be 1. All right? Now, if I have an angle here, I'm gonna just call it, so I'm gonna call the angle here, I'm gonna call it theta. And so the opposite side to theta is gonna be this side, the vertical line, and is the one that is right across from it. So this is the opposite side. And the other one, the one that is making the part of the angle, actually the initial side, I should call it, is the adjacent side. So we could also say that the opposite side could be given by the y coordinate. And for the adjacent side, that could be found with the x coordinate, like that. And so that's why we have them written in this way. So the opposite side is y over 1 is just y. Now for cosine, we have adjacent side. In this case, it will be the x. And the hypotenuse for the unit circle is 1. So x over 1 is just x. And then for tangent, if we take the opposite side from this angle here, from this angle, the opposite side will be y. And the adjacent side will be x. And so that's why we have, for tangent, we have y over x. And what happens if x is 0? Then the tangent will be undefined. And that is okay. We could have some trigonometric ratios be undefined, and some could be equal to 0. They're not the same, okay? 0, because someone told me earlier 0, so it doesn't exist. That is wrong, because 0 does exist. It means nothing. I mean, actually, no, that's wrong. It just means 0. Undefined is different. That means it doesn't exist. Okay, so now remember how I told you that they're reciprocals of each other, right? So sine goes with cosecant. So in this case, if we have y over 1 and we take the reciprocal of that, we will obtain 1 over y. And for cosine and secant, if we get the reciprocal of that, we will get 1 over x. And notice how here the x cannot be 0, and for this one I forgot to mention y cannot be 0. Okay, and then for cotangent, it is the reciprocal tangent, so we take this one and we just interchange numerator and denominator, or you flip them, right? You know what I'm talking about? And so that will be the cotangent. Okay, so let's see how that's going to help us with example 1. So I need you to remember, so we're going to be talking about this angle. It is in standard precision, don't forget that. Standard precision means that the initial side is the positive x-axis, and then the terminal side, and and the vertex is at the origin, or the center of the circle. That's standard precision. So this angle, we're going to call it T. And because this is a unit circle, all I need is y and x, and then I can find everything else. So you can see the x and y coordinates here. This one is the x, and this one here is your y. So for sine of that angle, we'll just take the y coordinate, which is the square root of 3 over 2. And for cosine of angle T, we take the x coordinate, which is negative 1/2. And then, so we have those two, right, just from the point. Now, how can we find tangent? Well, we're going to divide y over x. So we take the square root of 3 over 2 divided by negative 1/2. So we're going to do the sandwich process, I guess. And so we multiply the two quantities on the outside. And then the one on the inside, so that will be negative 2. And then we need to simplify it. So this is going to 2 divided by 2 is 1.
Negative square root of 3.
So it will be negative square root of 3. Why is it negative, Andrew?
Because You don't, well, the negative isn't cancelled though.
Very good. So we still have to account for that negative sign right there, okay? So negative square root of 3. Now, let's go ahead and find cosecant by using the reciprocal of sine, right? Bless you. So 2 over the square root of 3. And I know it says here 1 over y, but I'll show you how you will get the same. If you just take the reciprocal from this one, it's a lot easier. So here, every time you have a radical on the denominator, we need to get rid of it. So the way to get rid of it is to multiply it by itself, like that. Whatever we do to the bottom, we must do to the top. And so if we do that, think of this one here. It's like if you have the square root of 3 multiplied by itself, that will be the same as saying the square root of 3 squared. That will cancel and it will give us 3. And 2 square root of 3 for the numerator. Those cannot be multiplied because 2 is rational and 3 is irrational. Alright, now the reciprocal of secant, the reciprocal of cosine is secant, so that will be negative 2 over 1 or simply negative 2. And then the next one, for cotangent, we need the reciprocal of tangent. So that's going to be negative 1 over the square root of 3. And again, we need to rationalize. So we multiply by the same number as the denominator, which is the square root of 3. Actually, it's only by the, well, we'll get to that. And then this will be, what happens here if you multiply the square root of 3 times the square root of 3? Just 3. We're going to do a lot of this. You guys are going to be pros at rationalizing. And then on the numerator, we need negative square root of 3. That's it. So the 6 trigonometric values or function values are that, here, and here. When you guys do your homework on my math lab, you have to rationalize. If you don't rationalize, they're going to count it wrong. Okay? All right, my friend. Okay, so I'm going to move to the next one. It's very similar. Let me see what's happening. Yeah. Actually, you guys do that one. So you're going to use the point that you see here. Now both are positive. You have x is the square root of 3 over 2. Y is equal to positive 1/2. And remember that you need the cosine is given by the x and the sine is given by the y. Remember that. Don't look at the previous example. Just look at this. So we have the first two. Sine is given by the y coordinate 1/2. Cosine is given by the x coordinate, the square root of 3 over 2. Now to find tangent, we need y over x. So 1/2 over the square root of 3 over 2. And so that will be 2 over 2 square root of 3. And so that will cancel. We'll have 1 over the square root of 3. And if we rationalize, we're going to end up with the square root of 3 over, what happens when you multiply a root by itself? 3. So it cancels the root. Okay, now let's find cosecant. So as a reciprocal sign, we need to flip the 1/2. So that's easy, right? What is it?
2.
Just 2. 2 over 1 or just 2. Okay, the next one, flip them, so 2 square root of 3. So then we multiply by the square root of 3. Top and bottom, remember, because we don't want to change it, we just multiply them by 1. And so that will be 2 times the square root of 3. And on the bottom, we need
3.
3. There we go. Okay, now cotangent. We could get the reciprocal of this one, or we could do something easier and just take the reciprocal from here before we rationalize. Do you guys see why it will be easier? Because it will just be the square root of 3 over 1 or the square root of 3.
Yes.
Now, if we were to take the reciprocal of this one, it would be the same. It would be 3 over the square root of 3. Then we rationalize. So then it will be 3 over the 3 square root of 3 over 3. Those two cancel, and then you get the square root of 3. So do you see we saved all those steps by just taking the reciprocal from here before rationalizing? That makes it a little easier. Okay, we're going to do several of this. If you're still not getting it, don't worry. I'm going to keep doing them. Don't hate them yet. They become fun once you know what to do. Okay, the next one is pi over 2. This one is very easy. So remember, sine will be given by the y coordinate, okay? So we're talking about pi over 2. What is that in degrees?
90.
90. So pi over 2 is the same as 90. Don't forget that.
We'll do that.
All right, so we have here sine. So that's the y coordinate. We're going to look at the angle that comes from here. This is standard position, initial side. And then the angle goes like that. And then here is the terminal side. So the terminal side has those coordinates. So for the sine, we take the y coordinate, which is 1. What about the cosine? We take the x coordinate, which is 0 from here. That's very easy, right? Yeah? Okay, now what will the tangent be? 1 over 0. And what happens here? So this becomes undefined. Okay. Now let's do the reciprocal ratio. So the reciprocal of 1 is just 1. What about 0? What's the reciprocal of 0 over 1?
Undefined. 0.
So 1 over 0, which is undefined. Okay. And then for cotangent, we take the reciprocal of this one, and that is 0 over 1, or just 0. Very good. So the solutions for those 6 ratios, sine of pi over 2 is 1. Cosine is 0. The tangent is undefined. The cosecant is 1. The secant is undefined, and the cotangent is 0. All right. So I want you to talk to someone. If you have a partner, if you don't have a partner, just talk to yourself. And make a conjecture about what's going on here with the zeros and the undefined. Is it coincidence or not? Don't say it out loud.
No, I don't think it's a coincidence.
Okay, so what is the deal here? Okay, so if a trigonometric, you're going to finish the statement for me. If a trigonometric ratio is equal to 0, then its reciprocal is undefined. Oh, I just gave you an answer. So is undefined. Is that what you guys thought?
Yeah.
Okay, what is the converse of that? Like in reverse. Say it, Garrison.
It's reciprocal.
If a trigonometric ratio is,
If a trigonometric ratio is undefined, then its reciprocal is equal to 0.
there you go. So this is one of those, if P then Q, and if Q then P, so then it's a double if, double arrow. Yeah. Okay, now let's do the next 3. I mean the next 6 for this other angle. And this is for pi. So initial side, positive x-axis because that's standard position, right? Don't ever forget that. The saber gets really, really mad when you forget that. And then you go in this direction because it's a positive angle, so we go counterclockwise. And this is the terminal side. So then we take the coordinates of the terminal side. So then let's see, sine of pi. You guys write those down. I'm just gonna. Okay, so sine of pi, what is that, Matthew? Y coordinate, tell me the y coordinate.
We're on 0.
Very good. Cosine of pi, will you? Regina, tangent of pi.
Another 1.
0, very good. So it's 0 over 1, and that makes it 0. Very good.
Mr. Cosine is negative 1.
Oh, it's negative, I'm sorry. So would this be negative 0? That doesn't exist. It's just 0. Okay, so then what happens with cosecant? Since sine is 0, cosecant should be undefined.
Oh.
Why? Because it will be like 1 over 0, so that is undefined. What about secant?
Negative 1.
Negative 1 still.
Undefined.
And if tangent is 0, then cotangent is undefined. Okay, let's see if we can do the next one. Alright, yeah, this one is pretty easy. Okay, right before the break, I want you guys to think of the following. So, I believe it's like section 4.5, we're going to be graphing sine and cosine. If you want to get a little preview, I know you guys have seen waves, right? Maybe in physics? Okay.
Yeah,
The ocean. Yes, actually the tide is it could the way it goes up and down could be represented as a circle. Sound waves also. Gamma rays, X-rays, all of those are waves. Wi-Fi, they're waves. Yes. And that's why trig is so important, and it's actually used a lot in many fields. So once we get to those graphs, of course, they're going to have a domain and a range. So for both of those functions, so we're going to call the domain, it's like the input, right? So when we talk about the sine function, like something like sine of theta, so the input happens to be the angle. So what do you guys think will be a good set for the angle? Can angles be positive, negative? Could they be 0? Yes, yes, to all of those. So the domain will be all real numbers. Also for the cosine function. This is the for the input, which is the angle, it will be all real numbers. Now, once we get to the range, which will be the output, remember that. Let's look at the circle, at the unit circle. So we already know that sine is given by the y values, right? So can you guys tell me from this circle here, what is the smallest y value? Right here. -1. And the largest? 1. So what that means is that our outputs will be between -1 and 1, including -1 and 1. If I was to draw that sine wave, this will be positive 1, and this one will be negative 1. But we'll learn that in section 4.5. Now let's look at the cosine. So we're going to look at the x values here. So what is the smallest x? Negative 1. And the largest? 1. So here for the output, we're going to have the same thing. Negative 1 to 1. So that means if I give you a question that says something like sine of theta equals 2 sine theta, this will have no solution. Why? Because the 2 is past the 1. So all of our numbers, like in a number line, that would be a no solution. So in a number line, your sine and cosine outputs or ratios will be between all these numbers in between. They cannot go below negative 1 or past positive 1. Okay, so go to your break. I'm going to pause the video. What we're going to do next is find the trigonometric values at pi over 4. You might remember what they are. They're kind of easy. Square root of 2 over 2. But just hold on. We're not going to find all the 6 until I show you why is it square root of 2 over 2. Okay? Please pay attention. I'm not going to test you on it, but this is good for you to develop another way of thinking. So, we have the equation of the circle, so I'm going to start with that. X squared plus y squared is equal to 1. Now, what do we know about a triangle? Right triangle where one of the angles is equal to pi over 4, which is equivalent to, what is it in degrees? 45 degrees. Now, what is the sum of the interior angles of a triangle?
180.
180. So if this is 90, and this is 45, the other one has to be 45. Very good. So if the two angles are congruent, then we could also say that these two sides are congruent, right? And we know this as an isosceles triangle. Okay, I cannot spell right now. So we're just going to say isosceles triangle, right? And so, oh yeah. So if we put this triangle here, right here, in the unit circle, what is their hypotenuse equal to? The radius, which is 1, right? This is the unit circle, remember that. Okay. Now, if I want to call this side, I want to call it A, and I want to call this one B, isn't it true that this side is equal to this side? So I can say that B equals A. Yes? Are we comfortable with that? Two sides are equal. So then if A equals B, then this point here is actually just A comma A. Because it's like the same number with B. So let's say that I want to replace the x coordinate with A, and I want to replace the y coordinate with B. But then I'm going to use my statement from here that A equals B. So I'm going to replace B with A. Very good. Now, how many A squares do we have? Two of those.
2a squared.
And that equals 1. Now, we're going to solve for A. First of all, what's the 2 doing to A? Multiplying. So we need to divide. 1 over 2. And then square root both sides.
Yeah.
So that will be A equals square root of 1 over the square root of 2. So then A is equal to 1 over the square root of 2. But, however, we need to rationalize, right?
So b square root of 2 over 2.
I don't know. Let's see. So that's square root of 2, and then here, remember, a root by itself, cancel the root. Good job, Andrew. That's why you should come back to science club.
Huh? Science?
Mm-hmm.
You weren't science? Oh! For like 1 day?
For 1 day. Mm-hmm. Okay. Josiah, put your phone away. You're texting too much. Okay. All right, yeah. So this side is equal to the square root of 2 over 2, and this one is also equal to the square root of 2 over 2. All right, now that we know all of that, we could say that the cosine, so if we go by the opposite side, right, it will be the y coordinate here, and the adjacent side is the x coordinate. So then the cosine at pi over 4 will be the same. And then the tangent, what do you get if you divide a number by itself?
Square root of 2.
No,
Or, I mean, wouldn't that be 10?
you get 1.
Oh, right.
Yes. So that is the easiest tangent of all. 1. The tangent at pi over 4 is 1. Okay? Don't forget. Okay, now let's find the reciprocal ones. You guys love shortcuts, so just take the answer before we rationalize it. Where was it? Oh, right here. The 1 over square root of 2 and get the reciprocal of that one. So 1, I'm sorry. So this is equivalent to 1 over the square root of 2. The reciprocal of that will be the square root of 2. And the secant, we take the reciprocal of, again, 1 over square root of 2. And that will be the square root of 2. Remember, I'm using this one because that was the answer before I rationalized here, right? Before rationalizing, because that's easier. You just have that in, you flip them, you just have the 1 on the bottom. Okay, let's finish this with the cotangent. So what is the reciprocal of 1? The reciprocal of this one is 1. And that's it for pi over 4. Okay. All right, so even and odd functions. So I'm going to give you a little review from Pre-Cal 1. So we used to refer to even functions with this notation, f of negative x is equal to f of x. And for odd functions, f of negative x is equal to the opposite of f of x. So let me show you some quick examples. We used to use parabolas to show you that. So like, for example, if this is x squared, f of negative 2, what is negative 2 squared?
4.
4. And what is f of 2?
4.
What is 2 squared? It's also 4. So that's why that is an even function. Now, for odd functions, we commonly use the cubic function, parent function. So, for example, if I ask you what is f of negative 2, that will be negative 8. And what is f of 2, what is 2 to the third power? So 2 times 2 times 2. So that would be 8. But the negative sign from here, it carries over. So that's what it means to be an odd function, okay? That was like in pre-cal. Now, those properties can also be used for sine and cosine. And if you do take calculus, you will find them pretty useful because they can help you just cancel like many steps, just if you know that the function is odd or even. So for example, let's look at the circle, and let's look at those 2 points, P and Q, right here. Okay, so we already know that the x coordinate will give us the cosine. In this case, the angle is negative t, okay? So this will be negative t. And the y coordinate of this point is going to give us the sine. Now, if we look at this point up here, point P, same thing, but in this case, the angle is positive, positive T. The one in blue is negative because it's going in the clockwise direction. You guys remember that? Positive and negative angles. Positive go counterclockwise, negative angles go clockwise, like the hands of the clock. Okay, now the coordinates of point T, of point P here are going to be, for x, we take the cosine of t, and for y, we take the sine of t. Like that. Okay, so if you look at both points, what can you tell me about the x coordinates? They're the what coordinates? Same. So for P and Q, the x coordinates, they're both positive, right? Are the same. So what this tells me is that the cosine of the negative angle is equal to the cosine of the positive angle, right? The x values are the same for this point and this point, isn't it true? I'm not going to test you on this either. This is just to show you why they're odd and even. It's a little hot. Okay, now let's look at the y coordinates, guys. For P and Q. Well, before we finish that. So if this happens, it's similar to here. So what are we going to say? That cosine is even. Now for P and Q, the y coordinates are what? Say that again? Very good. Opposites. They have opposite signs, right? We don't know what the number is. We just know they have opposite signs. So are opposites. Just like the odd functions. So we're going to say that because of that, the sine of negative t, this one here, is going to have the opposite value of sine of t. So that's why we have to put that negative in front of it. That's the opposite. And then positive angle. So that tells me that sine is odd. Okay. All that stuff is written here. Okay? So, we have cosine is even. So, the reciprocal of cosine is also even. Okay? And then sine, we already proved that sine is odd. So then the reciprocal for sine is also odd. Now I'm going to show you just quickly why tangent is also odd. So tangent, you already know that it is the y over x, right? Or we may say the opposite side divided by the adjacent side. Another thing we could say about tangent is that it is the same as sine, right? Because sine is the y. Over, what did we use instead of x? Cosine. And this is going to come in a minute, in a couple of slides. And so, let's say that I want to write the following. Tangent of a negative angle. Right? So I'm going to use this notion here. This is called the quotient identity, because it's a quotient, so I got division. So if I do that, I'm going to write sine of negative t divided by cosine of negative t. Now, based on our knowledge from here and here, sine of negative t is equal to minus sine of positive t. And then according to this one here, what is cosine of negative t? Is equal to cosine t. So this one here happens to be the opposite of tangent. So therefore, tangent is odd. So what are the only two that are even? Cosine and secant, that's it. How does that help us? Just to determine that if a function is even, if I ask you, what is the cosine of pi over 4? The square root of 2 over 2. So because you know that cosine is even, what if I ask you, what is the cosine of negative pi over 4? Is the same as this square root of 2 over 2. You don't even have to think about it. It's just the same. Now, if you have sine, which is odd, and I ask you, what is the sine of, let me think about a good one. Oh, well, let's just use pi over 4 again. What's the sine of pi over 4? Square root of 2 over 2. Now, what is the sine of negative pi over 4? Now, you cannot say like cosine is the same. You cannot say that. But instead, you're going to say is the opposite of that one. So it's going to be what?
So will we take the negative?
Negative. No reciprocal, just
Oh,
negative. Just negative. Square root of 2 over 2. All right, so we're going to do a couple of those examples in the next slide. Okay, so cosine, right away, you already know, oh, we already did that one. So cosine is even. So because it is even, the cosine of negative pi over 4 is equal to the cosine of pi over 4. Just because it is even, that's why. And the cosine of pi over 4, we already know it, square root of 2 over 2. Okay, now let's work with tangent. Tangent is odd. So because of that, we can't really say it is the same as the positive angle. Tangent is the positive angle. In fact, it's the complete opposite. So negative and then tangent of pi over 4.
Negative 1.
So we carry the negative, and then what's the tangent? 1. Why is the tangent of pi over 4 1? Because the sine and the cosine are the same. So what happens when you divide two numbers that are the same? You get 1. Okay, do we have any questions so far? This is like a lot of new stuff that perhaps we haven't seen before. You're still taking geometry. They don't cover trig. Well, in physics, you guys have studied this a little bit. Okay, so let's do the next two. You guys do those. So secant is odd or even?
I mean, even.
Even. And sine? Odd. Oh, let me show you a trick that I used to use when I was younger. Not too long ago. When I was in high school. So sometimes, people get confused with The sine, is sine the reciprocal of cosecant or secant? So I'm going to show you a way to remember. You always want to have S and a C, or C and S. Okay? So SC, CS. Never, I know it will make more sense if sine was with secant, right? But it's not, unfortunately. So just remember, you have to have S with C, C with S. That's how you don't confuse them. Okay, work on that, right? Check point 4. Okay, so let's check our answer. So for the secant of negative pi over 4, still talking, that's going to be, secant is odd, even, so it's the same as the secant at pi over 4. And so we all know, right, that the secant of pi over 4 is the square root of 2. Okay, for sine is odd, so the sine of negative pi over 4 is going to be equal to the opposite of sine of positive pi over 4. And so we all know that the sine of pi over 4 is the square root of 2 over 2. And this negative sign is carrying over from here. Yeah, do you guys get it right?
Yeah.
If you didn't, correct it. There's nothing wrong with that. Okay, so I'm going to flip the page. Reciprocal identities, we've been talking about it since the beginning of the class, right? Remember? So you just flip them. The fact that you have 1 over, that is actually what being a reciprocal means. Then we have quotient identities because you are like dividing here, right? So those are like ratios or division. So that's why we call them quotient identities. So we have the one for sine, meaning for tangent, because that is y over x, so it's sine over cosine. We also have the reciprocal of tangent, which is cotangent, and so it makes sense that we just flip the cosine and the sine, right? Because cotangent is x over y. Okay, now my favorite of all identities is this one here. And I call it the lifesaver. You will learn why. Yes, literally. When you're about to like pull your hair. Yes. Why? Because every time we're solving problems and we encounter a sine square and a cosine square of the same angle, we can cancel them out. If they're adding, we cancel them out and we just put a 1 in there. And trust me, that's going to cut us a lot of steps. So that's why I call it lifesaver. Okay? Don't ever forget it. Why do we call it Pythagorean identity? Because it's kind of like the Pythagorean theorem. So if we go like a squared plus b squared equals c squared, right? And so we're talking about the unit circle. What will be the hypotenuse? 1. So it's just 1 square here. And then for a and b, this will be like your, like if this is a and this is b, so we can call this cosine of t, just to keep with that. So cosine of t squared plus, and then b will be here the sine of t. Square, and here we had a 1, right? Now, it's important to notice that, to tell you that when you have a square here, what you're squaring is the whole expression sine, not the angle, okay? Are we clear with that? So what it means, it literally means this, sine of t times sine of t. That's what it means. This is good to know. Okay, so now from the lifesaver identity, my favorite of all, don't ever forget it. Here, we can derive the next two. So I'm going to derive the first one. No, actually, I'll derive the second one. And then you guys are going to derive the first one, okay? Okay, and so here we have, I'm going to start with the Pythagorean identity, sine square of t plus cosine square of t equals 1. So what I'm going to do is divide everything by sine square of t. Everything. Okay. Now from the first one, what do I get if I divide something by the same something? Cancel 1 and equals 1 or 0? What is like if you divide 10 by 10? 1. So this is just 1. And then based on the quotient identities, what is cosine over sine? Here? Not tan, cotangent. But here we have square, so we're just going to put cotangent square. And then based on the reciprocal identities, the very top, what is 1 over sine?
Cosecant.
So cosecant square of t. And that's how we get that one right. Okay, now I want you guys to prove the other one, please. So to get started, instead of dividing by sine square, go ahead and divide everything by cosine square. And then see what you get. Just give it a try. Come on. Feel free to talk to your partner. Okay, so the solution is here. What you need to do is start with the Pythagorean identity, and then we divide everything by cosine. As long as you do it to both sides, you can do it. It's okay. You can do whatever you want. You can multiply the whole equation by 100, and it will still be the same equation. So then, good question, could we have tangent square of the angle plus 1? Is that the same as what we have here? Yes, they are the same because addition is commutative. So yes, that's okay. Now, I'm going to test you to do something like this, not in the section, but when we get to chapter 5, yes, it's actually 5.1. Okay, now here, we're going to use the quotient and reciprocal identities. So let's see. If the sine is 2 over 5, the reciprocal of sine is? Which one?
Oh, cosecant.
Cosecant, remember, SC. So you flip the numbers, 5 over 2. Okay. Now we have here cosine of t is the square root of 21 over 5. So what is the reciprocal of cosine? So 5 over the square root of 21, and we need to rationalize.
Square root of 21.
Let me finish. Okay. And then finally, tangent. 2 over 5 divided by, so we're using, actually I should write this. Quotient identity, that is the sine over the cosine. So that will be 2 over 5 divided by square root of 21 over 5. That will give me 2 times 5 if I multiply the outer quantities. And then the inner quantities, that will be 5 times the square root of 21. Here we can cancel the 5's. We'll have 2 over the square root of 21. And then if we rationalize it by multiplying the square root of 21 top and bottom, we'll get 2 times the square root of 21 over 21. Oh, and now we need to find one more. Which one? Thank you. So the cotangent, we're going to get the reciprocal of tangent, but let's find the one before I rationalize. That will be a lot easier. Where is that at? Right here. So the reciprocal of that one is the square root of 21 over 2. I'll leave it there for a minute so we can finish writing. Alright, for problem 6, we're going to use the Pythagorean identity, and that is the one, my favorite, sine square of t plus cosine square of t equals 1. Now remember how I told you that if you have a square, what you're squaring is the whole angle. So this actually means the sine of t, and then we square it. And this one means the cosine of t, and then we square that. Okay? So we are given this value for sine of t is 3 over 5. But then I have to square it. Yeah, are we clear on that part? So you're going to square the whole fraction. We do not know this one. That's the one we're looking for. So if here we square 3, we get 9. We square 5, we get 25. Here we just have cosine square of t. I'm going to write it out this way. I want you to get used to both notations. Now, if I would have solved that, I'm going to have cosine square of t is equal to 1. And then I'm going to take this fraction, which is positive, across, and it will turn into negative 9 over 25. So 1 in terms of 25ths is 25 over 25, right? Is that correct? Yes? And so I have to do that because I want them to have the same denominator so I can actually subtract the two fractions. So 25 minus 9 is 16. All over here I have still cosine square t, cosine square t. And so now what I need to do is take the square root, you all know that. So the cosine of t is going to equal to 4 over 5. However, when you take a square root, it could be positive or it could be negative. But the problem is stating that they want the angle to be between 0 and pi over 2. So all the angles between 0 and pi over 2 are in which quadrant? First quadrant, yes. So this is 0, this is pi over 2. So we're talking about an angle anywhere here. So if we're talking about the cosine, is that the x or the y? Cosine is the?
Cosine is the x.
X. Will the x be positive or negative in the first quadrant? Positive. So then that's why we only take the positive root. And that's why it's only positive 4/5. Okay? Only because they wanted the angle, and the questions, you know, they're very picky about that. They want the angle to be in between there. If they had said we want the angle to be in the second quadrant, then you would have taken the negative root instead. Okay, we're almost done, I promise. Okay, this is a long section, I know. Periodic function. So let me give you all the function of life. This is how all of you were born. Oh yeah. No,
That's how I learned I was born.
this is anatomy.
Calculus.
This is anatomy and physiology. So let's see, ladies. Don't get uncomfortable, guys. This is perfectly normal and natural. How long is our period? Our menstrual cycle? Yes?
3 to 8 days.
Okay, it could last that long, the bleeding part. But our cycle, how often, let me rephrase the question, how often do you get your period?
month.
28 once a month.
Every
Thank
month.
you for sharing, Andrew. And so every 30 days, no, that tells me that you're comfortable with that. That's good. Every 30 days, 31. Some women get it like 25 days, every 25 days. And so your body goes through this whole hormonal change. And that's why sometimes if you have a sister,
Yes.
or perhaps your mom, no
Yes.
offense to any mother out there, maybe at some point they're a little more snappy. Have you guys noticed that? And so that's because their hormones, of course, they don't go from -1 to 1. This is just the sine function. But, you know, they go up and down and up and down, and that happens in an average every 28 days. Another example of a periodic real-life function, the tide of the beach, the ocean. It goes up and then it goes down. It goes up and it goes down every 12 hours. So when we have a function of sine and cosine, the period for them is the same as the complete circle. How many radians are in the circle? Regina, pay attention to me. How many radians?
2 pi.
2 pi. So if this was not the menstrual cycle, if this was just the sine function, this from here to here, it will be 2 pi. Okay? And for cosine, it's the same. It will be 2 pi. So that's what we have here and here. Do you guys remember something about coterminal angles? How they make like maybe one more turn, but they ended at the same point? That is the same thing. So for example, if I ask you the sine of, actually it's a question, let's just answer it. The next one. The sine of 9 pi over 4 is the same as the sine of, I'm going to split this fraction into 2 fractions, like a mixed fraction. How about we do that? You guys know how to do mixed fractions. What do you do? Not Andrew. 9 over 4. What is that as a mixed fraction? 2 plus what? 1/4. Thank you. So the sine of 9 pi over 4 is the same as the sine of 2 pi plus 1 pi over 4. Yeah, do you guys get the idea? I'm using the same numbers as this. Sorry for you guys who want to say that, but it's a college class. Oh, this is recorded. Sorry. This is a college class. We don't recite Pledge of Allegiance in college. Too bad. Okay, so based on the previous slide, what is the sine of 2 pi? If it repeats, then that should be equal to just the sine of pi over 4. Do we all know the sine of pi over 4? Of course we do. And that's it. Now let's do the next one, tangent. Tangent of -5 pi over 4. First of all, tangent is odd or even? Odd. So since I have a negative angle, I could say that it will be the same as the opposite of the tangent with the same angle but positive. Now I need to go back to the slide because I forgot to mention something. The period for tangent is not 2 pi. It's actually pi. We'll learn why later on. And so, for example, if you have an angle here at pi over 4, and then you add another pi, you're adding 4 pi over 4 plus pi over 4. So how many pi over 4s do we have? 5 pi over 4. So this angle right here, which is 5 pi over 4, is going to have the same tangent value. What was the tangent of pi over 4? The easiest of all.
1.
1. So what is the tangent of 5 pi over 4? Also 1.
Teachers and students, pardon the interruption. One final.
Let's turn 5 pi over 4 as the mixed fraction. So that's going to be what? Okay, Andrew, you can participate.
1 over 4.
1.
Pi over 4. 1 over pi over 4.
And if you need to add or drop a college class, today would be the last day to take care of that. Thank you.
Oh God, she sounds curious. I know, I'm just gonna go home. I'm just gonna go home. And so that is what? Negative 1. Yay!
Alright.
Okay, I'm just gonna stop here.